there is a history. And in fact, we are all products of history. So I thought I should start at the beginning with some history. This is where should I turn? Yeah, that's right. Oh, I turned this. You see, you're all very young people, except the teachers, some are older. So it is better just to sort of start by seeing how science and technology have changed our lives, first of all. Just about 100 years ago, life expectancy in our country was around 30 years. Now it is something like 67 years. Just about 40 years ago, this I am personally have felt this. If you wanted a telephone connection, you have to apply, wait for a decade, 10 years before you got the connection. Now you just go to the shop across the road, buy one and start talking in about 15 minutes. Then the internet, I'm quite sure all of you use it almost daily, enables to get any information you want instantaneously. This is something remarkable. It has happened for the past 20 to 25 years. Then all kinds of electrical gadgets like bulbs, fans, seats, and so on. You can think of any number of things that made life somewhat comfortable. In fact, quite comfortable. And of course, we also have a lot of entertainment. We started with cinema theaters, then television screens. And of course, these television screens are becoming bigger and cheaper as time passes. And modes of travel have also increased. I just came from that. So how has all this happened? Modern technology has mainly grown out of a detailed understanding of how nature works. Repeatable experimental measurements, quantitative measurements. This is at the basis of all technology. This started only about 40 years. How did this process begin? That is the question I am going to ask. And I am going to argue that glass, the ordinary glass that we are familiar with, has played an extremely important role in this development. Therefore, I will briefly, firstly, sketch the history leading to this epoch, when glass became a central player in this development. So let me start very early. I am not going to the beginning of the universe and so on. Let me just start with Homo genus, bipedal. Such a being evolved only about 4 or 5 million years ago in Africa, somebody. And now the hands were no longer needed for locomotion or movement. So you could use hands for manipulating material. This was a very important development in the history of human development. And recently people have suggested that the capacity to store energy, of course I am not a very muscular person, in your shoulder muscles, it allowed Homo erectus to throw stones, to hurt and kill big animals. This was very important part for human development. In fact, things like this become extremely important in evolution. Then Homo habilis, this genus, learned to start and control fire to cook food about 1 million years ago. This again, people who know these things tell me that this was very important for the development of his brain. Which comes next? Modern human, Homo sapiens, we belong to that genus almost. It evolved only about 200,000 years ago. It's a very short period of time in the history of man. Even our history, what? And And this had a relatively large weight. All our brains are relatively large compared to the rest of our body, compared to any other animal, including elephant. And this could start, this being could start shaping materials for the first time. It was not just using the materials available, but it could start shaping. This is very important for specific uses, and that is technology. This technology, of course, we started with stone tools to come. Agricultural societies came next. That was about, so we are rapidly moving forward 1,000 years ago. In the vicinity of the Tigris, Euphrates rivers, present-day Iraq, where there's a lot of problem right now. Sir? And we all come belong, yes, please. I'm sorry? Oh, you are unable to listen there? What should I do? Should I put it closer to my mouth? Sorry. I'm glad that you told me. Anyway, I'll hold it in my hand. Is this better now? Okay. So I can hold it very close to my mouth. So agricultural societies, they started only about 12,000 years ago. And this agricultural activity spread slowly out of the world. Anyway, people migrated out of Africa, had migrated some 70,000 years ago from Africa. But agriculture came as a wave at a later stage. And we are all finally from the Indus Valley civilization, Harappa, Mohenjo-daro, we all learned about them in history class. They could make bronze utensils. These are replicas from the Harappa, Mohenjo-daro culture. About 5,000 years, it's about 3,000 BC. The oldest science, of course, now we have to talk about science. The oldest science is astronomy. And this is very clear why that is the oldest science. Problem. You see every day sun rising, setting. Then agriculture needs knowledge of the seasons. Rainy season, summer, when should you harvest, when should you dry your seeds, and where you should store them, how you should store them. So all this needed a detailed knowledge of the 4 seasons. And of course the solar and lunar eclipses. But more importantly, the rare but sudden appearance of comets. This was very disturbing. Even the eclipses were very disturbing because it was something which is unexpected and for the early human beings. Then some very careful observers realized that a few so-called stars wandered in the background of other mostly stationary stars. These are the planets. So they found that there are some stars which do not stay in the same place. So these were called planets. Of course, my life, as usual, was very challenging. It's certainly was not as comfortable as it is nowadays. And some were lucky. Most people had to struggle. Now, it was therefore very tempting to relate the events in one's life to the motion of these planets. So astrology, it's not science. Astrology was born. That's one of the first activities. So people could calculate, for example, the eclipses, and then try to somehow relate it with what happens in your life. The belief in this connection of the connection between the zodiacal sign of birth and whatever happens in your life. This is astrology. This became so strong that accurate predictions of the eclipses and positions of these major planets became very essential. In fact, there is a connection to science. That's why I'm telling you all this. So, measurements. So when you want to predict things, you want to measure. So measurements became important. Not for any scientific purpose, but for making good astrological predictions. And of course, astrology continues to dominate. You go to any country in the world for that matter, if your newspaper has to sell, it must, as an obligatory thing, maybe in the first page, have predictions for all of us. This, your zodiacal signs. Otherwise, it won't sell. So it's still very prevalent. The first calendars were made by about 8000 BC in Scotland. And these people divided the year into 12 months. But the Julian calendar that we use, it was commissioned by Julius Caesar in 46 BC. And this was based on the 365.25 days. There is a one leap year. Next year will be a leap year, for example. First, coming to the older civilizations, the periodic movement of Venus was already known to Babylonians in about 700 BC. The first model to explain the movement of planets, assuming that they moved on spheres around the Earth, was developed by the 4th century BC by the Greeks, and that was adopted by Plato and Aristotle, and later the Church. And this is again important for our story. Church adopted this model. In India, an astronomical text called Vedanga Jyotisha on the movements of the sun and moon was written at about 1300 BC, quite a long time ago. Aryabhatta, I am quite sure all of you are familiar with his name. He wrote a book on astronomy I think the people at the back can't hear unless it is very close to it. Can you hear me? Can you hear? Okay, you will please go on. So he wrote his Aryabhatiya, as it is called, in 499 AD, where he suggested that the Earth spins around its own axis. So he had already realized that. And he calculated the periods of various planets and so on. And the University of Nalanda, we are again told this in our history books, offered a course on astronomy in the 12th century. Now, about measurements. For astrological purposes, you have to measure the position of various planets as a function of the seasons, of the day, and so on. So people invented gadgets. The astrolabe, this is called an astrolabe. This brass gadget. These were made already about 2000 years ago, in the beginning of the Christian era, in brass. And they were used to measure the angular position of stars, planets, for astrological purposes, predictions. Of course, this also needed, you see, if you have to make prediction depending upon the time of your birth and so on, you need a clock. Mechanical clocks were made in Europe in the 14th century, but the Chinese apparently had made water clocks even much earlier. Chinese played a great role in some of these developments. Now we come to slightly more modern Copernicus. You are all familiar with his name. He was a Polish scholar. He came up in 1514 with the idea that the planets, including the Earth, rotated around the sun in circular orbits. That's what he said. Until then, you remember Aristotle, the Church, everybody said everything moved around the Earth. Earth was the center of the universe. Copernicus said, okay, well, of course, in a sense, Aryabhatta had predated him, but he didn't go so far as to say everything moved around the sun. He simply said Earth rotated around its own axis. But Copernicus made the next. He guessed that all these planets, and Earth was also a planet according to him, just went round in circles around the sun. That was in 1540, 500 years ago. And his definitive book was published in 1543, a few months after he died, because he was again afraid to publish it, because he knew what the church would do if he published it. Tycho Brahe, you have all heard his name. He was a Danish nobleman of the 16th century, again 1500s. He was deeply interested in astrology here. He made accurate measurements of the angular positions of stars and planets using the type of gadget that I showed you, the astrolabe, with the then available astrolabes, to an accuracy of 2 minutes of arc. This is very important because it shows he had an excellent eyesight. And we'll come to this point later. And he moved to Prague in 1597, continued his measurements with the assistance of an excellent gentleman called Kepler. Kepler was Tycho Brahe's assistant. Tycho Brahe died suddenly in 1601 from an unknown disease. Now Kepler, he was a teacher of mathematics. And Tycho Brahe had compiled, the position of Mars, very detailed fashion, several books over several years. Kepler, with his mathematical knowledge, could analyze that data. He realized that Mars was going in an elliptical orbit, not a circular orbit, as Copernicus said, in an elliptical orbit around the Sun, with Sun at the focus, at one of the focus. Kepler's first law of planetary motion was published in 1609, just around 400 years ago. He wrote several astronomical books containing all his 3 laws. You learn Kepler's laws of motion, right? Around 1620. And he also wrote several books on astrology. Of course, astrology, if you want to make money, you have to write books on astrology. Because those were popular, not astronomy. Of course, several religious scholars strongly opposed this Copernican heliocentric view, that is, Sun at the center, around which the planet is. So, a direct experimental or observational demonstration was needed to show which model was right. This is where glass comes in. Okay, so we finally, but let me talk a little bit about glass. In common usage, glass refers to the soda lime glass and or window glass. Sometimes glass, we say, also refers to a glass tumbler, glass of water. Sometimes glasses means particles. In physics, glass refers to a state of matter which arises in a supercooled liquid, where the molecules are now frozen still in their fairly irregular positions, as if they are in the liquid but unable to move. It is what can be called a solidified version of the liquid. It's always in a metastable state, not the really stable state. When you cool a liquid, is the crystallized. So this is a metastable state, where you do not allow the material to crystallize. Crystals have 3-dimensionally periodic arc, whereas a glass is a very irregular arrangement of the molecules. In physics literature, where you come across various other types of glass, for example, metallic glass, twin glass, etc. But we are not interested in those for our story. Nowadays, many polymeric materials, which are made of long-chain organic molecules, with names like polycarbonates, polyethylene terephthalate, etc., also form this glassy state. In fact, most probably the spectacle that I am wearing is a polymer, not real soda glass. Now, we are interested only in the soda glass. This is a semi-transparent silicate glass. It was already known about 5,000 years ago. See, this apparently formed when lightning struck some sandy area. Glass formed because of this lightning sand. This was known in Syria and Egypt 5,000 years. It was subsequently made in various parts of the world for jewelry, windows, tableware, all kinds of decorative items made of glass by heat processing of sand with various chemical additives. The first colorless transparent glass was made by introducing manganese dioxide to sand and heating it up to an appropriate temperature and then removing all the muck, cooling it down. That was done only in 2nd century AD. Though glass is known for 5,000 years. Of course, in the Indus Valley civilization, again, glass was used for decorative purposes by 1700 BC. Now, okay.
Why glass is transparent?
Well, it is an interesting question. You see, for example, if I take any metal that is not transparent, that is because, as I will subsequently tell, I am quite sure you know Maxwell's contribution that light is an electromagnetic radiation. Do you learn about Maxwell's contribution? That light is an electromagnetic radiation. In a metal, electrons are free to move. That is how metals conduct electricity. Okay? So if light, which is an electromagnetic radiation, falls on a metal, the electrons move with the oscillation of the electron. And this will absorb that light and reflect. So it will not allow the light to pass. On the other hand, in glass, the electrons are not free to move. It is an insulator. Once that is the case, unless you are close to an absorption band, as it is called, where there is a vibrational motion of the electron, it will allow the whatever radiation, in our case light, to pass. That is why glass is formed. That is because the electrons are bound in the silicate. So that is the main reason. No metal, and of course you can always take a very thin foil of gold. It will not be transparent, but some light passes. So it depends on the thickness. But in the case of glass, if you get a very high quality, what should I do? Huh? Maybe. You see, if I take a very thin foil of gold or silver, some light passes through it. But on the other hand, in the case of glass, you can have fairly thick. In fact, I am coming to say glass fibers and software. There are hundreds of kilometers. Light passes. So now we have to make a lens out of glass. The earliest known lenses were made using actually polished quartz crystals. The quartz again occurs naturally. Brazil, for example, beautiful big glass quartz crystals. This was done around 500 BC in Egypt. By 1st century AD, people realized that if you have a spherical cup and filled it with water, it acts like a lens. And this was used to magnify some small objects. But glass lenses, believe it or not, though it was known 5,000 years ago, the glass lenses were made only in 1,000 years. So, let's again recall. Glass is made by melting soda ash, sand and limestone. Mixed and heated above 400 degrees, it becomes a liquid. Then you cool it. Below around 400 degrees, it goes to this glassy state. Molecules no longer move. They get frozen in their positions, but it is not in the crystalline state. See, quartz is the equivalent crystal. It has a regular periodic arrangement of the silicon atoms, let us say. In the glass, the same atoms are in an irregular arrangement. That's the difference. Quartz has sharp edges. It is a regular crystal like diamond or sodium chloride, whatever crystals you are familiar with. On the other hand, glass, it has no natural, regular faces or corners or edges. So all that you have to make by treating, by special treatment of the glass. By itself it has no special shape. Now it is transparent, as one of your colleagues asked me. It is transparent. That is the other very important quality of glass. So it is used, I don't have to go through all this. You know it is used all of this. So this is a picture of, actually heated glass which is poured down, slowly it comes down, settles there, and it's allowed to cool. This is from a glass blower fan or whatever it's called. And this is the arrangement of the sodium, silicon, and oxygen atoms in a typical glassy structure. Irregular arrangement. The basic point to know is it's an irregular arrangement of these three atoms: sodium, oxygen, and silicon. Silicate glass. And this is a three-dimensional view of the same. Now, the color of glass can be very delicately controlled by addition of some suitable chemicals, cadmium, so on. And this gives rise to, there are some beautiful artistic creations made out of glass by exploiting. So these are very expensive art forms, mainly done in Italy, in a place like Burano. Coming to that, Burano plays an important role in our story. And in fact, it's a nice island near Venice, which I happened to visit when I was in Venice long time. Any number of glass artisans making all kinds of beautiful objects. Now, glass lenses, as I said, were made only by about 1000 AD. Around this time, books on optics were written in Arabic first, not in Latin or in by a gentleman called Al-Hazm. He also included his ideas about human vision. He realized that all the eye is lens. The first spectacles type of thing that at least I mean and some of you appear to be, using relatively thin glass lenses were made in Italy only by 1284. So till then, you had magnifying glass, you had to hold it in your hand and see, but nothing thin enough which you could wear so that it can, the thread can sit on your ears. It needs, you can't have a very heavy object. So they were made only in 1284. The first telescope, this is where the story begins. Finally, I come to the story of glass, changing the view of the world. The first telescope using glass lenses were made in Netherlands, actually, in 1608 by Janssen and Lippershey, two gentlemen, who realized that a convex lens at the front end and a concave lens at the back end, arranged in a brass tube, can magnify different objects. You can focus on them adjusting the distance. And if you look through this so-called eyepiece, which is the concave lens, you could see a magnified image of a distant object. This was made only in 1608, just a little over 400 years. And some picture of what their drawing made at the time was so good. But what do you do with this? You see, incidentally, the human eye is also a lens, a convex lens. Focal length is just a couple of centimeters, whereas in the telescope you need a much longer focal. This gives rise to what is called an acuity, or ability to resolve two points, separated by about 0.35 millimeter at 1 meter distance for a typical human. Human eye of any person, maybe I have much lower acuity, I'm much older person. This gives an angular resolution of only 1.2 minutes of arc. Now you understand Tycho Brahe's contribution. See, he had combined data and marks to an accuracy of 2 minutes apart. And you are working almost at the edge of the achievable that is possible. He had an excellent result. Telescope used a convex lens of a long focal. This is very important to give the